You're standing in a crowded restaurant when suddenly your nervous system becomes overwhelmed by the environment around you. The clatter of dishes becomes unbearable, conversations blur into white noise, and that flickering overhead light becomes intensely disruptive. Your brain, which moments ago was handling everything just fine, struggles to process information efficiently. What just happened isn't a character flaw or a moment of weakness. It's your sensory processing system hitting a very real biological wall. And the way your brain responds to that breakdown provides insights into how neural coordination actually functions. Most people think of sensory overload as simply too much stimulation, like turning the volume knob too high on reality. The popular understanding goes something like this: your senses are like separate channels feeding information to your brain, and overload happens when too much comes through at once, like trying to drink from a fire hose. It's a reasonable metaphor, and it captures something true about the experience, but it misses the deeper story of what's actually breaking down in your brain during these moments. The fire hose metaphor suggests that sensory overload is just about quantity. Too many sounds, too many lights, too many textures hitting you at once. And certainly, busy environments can trigger these episodes. But this explanation falls apart when you consider that the same person who melts down in a quiet coffee shop with just a few competing sounds might function perfectly well at a loud concert with thousands of people screaming, or why someone might handle a chaotic construction site during the day but become overwhelmed by the gentle hum of a refrigerator at night. The traditional model also can't explain why sensory overload often comes with such intense emotional reactions. If it were just about processing capacity, you'd expect people to simply become less accurate at identifying sounds or sights, maybe miss some details. Instead, what actually happens looks more like a complete system failure: anxiety, panic, sometimes rage, and an urgent need to escape. These aren't the symptoms of a processing bottleneck. They're the symptoms of a brain that's fundamentally changed how it's operating. This gap between the common understanding and the lived reality has left millions of people, particularly those with autism, ADHD, anxiety disorders, and PTSD, struggling to explain experiences that feel overwhelming and real, but don't quite fit the neat categories that psychology has traditionally offered. To understand what's really happening during sensory overload, we need to think about your brain not as a single computer processing multiple inputs, but as multiple competing networks that must coordinate precisely. Marco-Pallares and colleagues' 2015 functional magnetic resonance imaging study revealed that sensory overload involves a breakdown in how your brain coordinates different processing systems, rather than simply being overwhelmed by too much information. Think of your brain as a city with two major transit systems. One system is like the subway network that connects you to the outside world. It processes sensory information from your eyes, ears, and other senses, and coordinates the responses that let you interact with your environment. When this network is running smoothly, you can track conversations, navigate spaces, and respond to what's happening around you with fluid, automatic precision. The other system is like the city's internal infrastructure, managing internal processes like attention, self awareness, and mental control. This system becomes particularly active during rest and introspection, but it also plays important roles in regulating attention and maintaining your internal mental state. In a typical brain operating under normal conditions, these systems work together in careful coordination. When you're actively engaged with the world, listening to someone speak, watching traffic while driving, reaching for a coffee cup, your external processing systems ramp up while internal regulatory systems provide appropriate support. When you need to concentrate internally or engage in self-reflection, the balance can shift accordingly. But here's where sensory overload reveals its true nature. Marco-Pallares and colleagues found something striking during sensory processing challenges. When participants faced overwhelming auditory environments, the normal coordination between processing systems became dramatically disrupted. Instead of external processing systems ramping up efficiently to handle increased sensory input, they actually became less coordinated. Meanwhile, brain regions associated with internal monitoring and control showed increased activation. It's as if the city's subway system started having coordination problems just as rush hour began, while simultaneously overloading the internal infrastructure trying to compensate. This disruption explains so much about what you experience during sensory overload. When your external processing systems start struggling, you lose the ability to effectively filter and process environmental information. Sounds that should fade into background noise suddenly compete for attention with equal intensity. Visual details that normally get automatically sorted and prioritized all demand conscious processing. Your motor coordination can become clumsy because the systems that usually handle automatic movement responses are struggling. Meanwhile, your brain's internal monitoring systems are working frantically to maintain control. This is why sensory overload often comes with such intense internal experiences, racing thoughts, emotional volatility, and that characteristic feeling of being trapped inside your own head while the world becomes simultaneously overwhelming and distant. Belmonte and Jurgelin Todd's 2003 neuroimaging work demonstrated that this coordination breakdown during overload involves increased activation in brain areas associated with cognitive control and emotional regulation. Your brain is essentially throwing available resources at trying to maintain internal stability while the external processing systems struggle. It's like a city having transportation problems while running the emergency management systems at maximum capacity. This mechanism also explains why recovery from sensory overload often requires specific conditions. You can't just power through or get used to the overwhelming input, because the problem isn't in your sensory organs, it's in the fundamental coordination systems of your brain. Recovery requires reducing the load on your external processing systems, enough that normal coordination can reestablish itself. The picture becomes more complex when we consider that this coordination disruption doesn't happen uniformly across all people or all situations. Research has focused on various populations, but sensory overload occurs across different brain types, and the underlying mechanisms may vary significantly. For individuals with autism, Sampson and colleagues demonstrated in their 2012 connectivity study that sensory overload might represent a more chronic pattern where normal system coordination is already somewhat different. Their functional connectivity analysis found that autistic individuals show baseline differences in brain network connectivity, which might make them more vulnerable to the kind of coordination disruptions that characterize overload episodes. But this doesn't mean autistic people are simply more sensitive. Thus, their brains may be operating with a fundamentally different coordination strategy that works well in many contexts but becomes problematic in specific sensory environments. The relationship between sensory overload and ADHD reveals another layer of complexity. While ADHD is often characterized as an attention regulation disorder, Ganizzetti's 2011 systematic review suggests that many ADHD symptoms might actually reflect chronic low-level sensory processing difficulties. The constant internal effort required to manage competing sensory inputs could drain the cognitive resources needed for sustained attention and impulse control. This would explain why ADHD symptoms often worsen in busy environments and improve in carefully controlled sensory settings. Trauma adds yet another dimension to this picture. Post-traumatic stress disorder fundamentally alters how the brain processes threat-related information, and this can dramatically change sensory processing patterns. Engel Yeager and colleagues, in their 2013 study of trauma survivors, found that individuals with PTSD often develop hypervigilant sensory processing. Their external processing systems become chronically overactivated, constantly scanning for potential threats. When overload occurs in this population, it may represent not just a coordination failure, but a trauma response triggered by sensory experiences that the brain has learned to associate with danger. The timing and development of these patterns also matters enormously. Ben Sasson and Carter's longitudinal work from 2014 suggests that sensory processing patterns established in early childhood tend to persist into adulthood, but they can also be modified by experience. Children who learn effective coping strategies for managing sensory overload show different brain activation patterns as adults compared to those who didn't receive early intervention. There's also the question of what researchers call sensory seeking versus sensory avoiding patterns. Not everyone who experiences altered sensory processing becomes overwhelmed by stimulation. Some individuals actively seek out intense sensory experiences. Current research suggests these might represent different manifestations of the same underlying coordination differences, but we genuinely don't know whether sensory seekers show the same coordination disruptions during their peak experiences. Perhaps most importantly, the field is still grappling with the relationship between sensory overload and broader questions about neurodiversity. The traditional medical model has tended to frame sensory processing differences as deficits or disorders that need to be corrected. but the emerging research suggests that these might be better understood as different neural strategies that work well in some contexts and poorly in others. The goal of intervention might not be to normalize sensory processing, but to help individuals understand their own patterns and develop environments and strategies that work with their brain's natural tendencies rather than against them. Understanding sensory overload as a coordination phenomenon rather than simply too much stimulation changes how you might approach managing these experiences in your own life. If you recognize yourself in these descriptions, the first insight is that sensory overload isn't a character failing or a lack of resilience. It's your brain responding predictably to a specific kind of coordination crisis. This reframes the entire approach to prevention and management. Instead of trying to toughen up or gradually expose yourself to overwhelming environments, the goal becomes learning to recognize the early signs that your brain systems are struggling to coordinate and developing strategies to restore equilibrium before full overload occurs. Pay attention to subtle changes in how you process information. Do sounds seem to take more conscious effort to parse? Are you having to think more deliberately about movements that usually feel automatic? Is your internal dialogue becoming more prominent or urgent? These might be early indicators that your brain is beginning to shift resources away from external processing and toward internal regulation. Environmental modifications become much more strategic when you understand the underlying mechanism. The goal isn't to eliminate all stimulation, but to reduce the coordination demands on your brain systems. This might mean choosing restaurants with better acoustics rather than quieter restaurants, or finding lighting that provides adequate information without requiring constant processing adjustments. Sometimes a slightly busier environment with more predictable patterns is actually easier for your brain to handle than a sparse environment with irregular or unpredictable elements. For those supporting someone who experiences sensory overload, this understanding shifts the entire framework of help. During an overload episode, the person's external processing systems are genuinely impaired. They're not being difficult or oversensitive, they're experiencing a real neurological event. Reducing demands for external interaction and providing time for the systems to rebalance becomes a medical accommodation, not an indulgence. The research also suggests that recovery strategies should focus on supporting system coordination rather than just eliminating stimulation. Activities that engage cognitive function in a calm, controlled way, like gentle problem-solving tasks, organized creative work, or structured physical movement, might actually help restore normal coordination more effectively than complete sensory deprivation. This has implications for workplace and educational accommodations as well. Instead of just providing quiet spaces, effective accommodations might involve understanding an individual's specific sensory processing patterns and creating environments that support their particular version of system coordination. For some people, this might mean noise-canceling headphones. For others, it might mean background white noise that reduces the coordination demands of processing unpredictable sounds. The next time you find yourself overwhelmed in a crowded space, remember that what's happening isn't a failure of willpower or a character flaw. It's a sophisticated neurological system responding to coordination pressures in exactly the way it evolved to respond. Your brain has systems for managing internal and external demands, and sensory overload occurs when these systems struggle to coordinate effectively, disrupting external processing while increasing internal control efforts. Understanding this mechanism transforms sensory overload from a mysterious personal failing into a manageable neurological phenomenon. The goal isn't to eliminate your sensitivity to overwhelming environments, but to work with your brain's natural patterns to maintain the coordination that keeps your systems functioning smoothly. Your nervous system isn't broken, it's just operating according to principles we're only beginning to understand.